Okay, so we are talking about 𝜖-NFA. So, just to formally define the language accepted by 𝜖-NFA. So, suppose we have a 𝜖-NFA q delta q0 f. So, this we know this is set of all states which are finite set. This is the set of all possible alphabet, and this is the starting state and this is the final state, and this is the transition rule, but here we have a this can take only one alphabet. So, or the empty string, this will go to the power set of q. Okay. And then we have extended this on sigma star to the power set of q, and then we define the language. So, if this is E, then the language of E, the 𝜖-NFA, is nothing but set of all w belongs to sigma star such that delta hat of q0 and w, this intersection is non-empty. Okay. So, then this intersection is not empty. So, this is a collection of all string which is reaching to the accepted state. We start with the starting state q0. So, we have a string w, which is a collection of alphabets, and we have a, suppose we have a tape like this, it is just we start with q0, and since it is 𝜖-NFA, we have epsilon move, we have moved to the non-deterministic move, we have moved to the many states. So, finally, if sum of the path we can reach to the one of the final state, then we say with this w along with the epsilon move, then we say this w is a string which is accepted by this 𝜖-NFA, and the collection of such string is called the language by the language of that NFA. So, let us take two quick example. So, we have seen this example before. q0 we have 3 state q1, q2 0, epsilon 1, epsilon 2, and this is the final state and this is the starting state or start state. Okay. And so, this is our E 𝜖-NFA. So, now we want to get the L of E, the language accepted by this. Now, 0, 1, 2 all are belongs to L of E, because any one of this. So, 0 if we start we can, so from 0 this is delta hat of q0 0, this we can reach to the, this is this q2 is a subset of this, q2 belongs to this. Why? Because we can start with q0 and with 0 we can be at q0, then we can move to epsilon move q1, epsilon move q2, final state. So, we are reaching to the final state. Similarly, for 1 we can execute this sequence from q0, we can have epsilon move q1 with epsilon move again at q1 and then epsilon move at q2. So, final state. So, 1 is belongs to 1 is a accepted string. Similarly, 2 also accepted string, we can just move to the from q0 with epsilon we can go to q1, with epsilon we can go to q2, and then with 2 we can go to q3, sorry q0, and with 2 we can remain at q2. So, this is the final state. So, this is the even 0 1, 0 1 it also belongs to L of E, because if we take 0 1, we can start from q 0, with 0 we can go to q 1, q 0 again, and from q 1 we can go to q 1 from q 0 with epsilon move, then with 1 we can go to q 1 again, then with epsilon move q 2. Okay. So, this is the way we can figure out 0 0, 1 1, 2 2, like this, any combination of this. So, all are reaching to this. So, this in fact, this language is all string with any number of zeros followed by any number of ones followed by any number of 2's. So, this is W W content. W is basically this is actually denoted by 0 star, 1 star, 2 star. We will define this regular expression in next after 2 lecture. So, this is basically denoting the any number of zeros, then followed by any number of ones, then followed by any number of 2's. So, this is the way we defined this. We take another example. We take another example. So, here suppose we are taking this as a plus dot, suppose arithmetic operation we are doing, and we have all the digit up to 9. So, this is our sigma, and what is our, so this is the starting state, and we can go from here to q 1 with a move either epsilon or plus or dot. Okay. And okay, we have a minus also. Yeah, so minus, we have a dot also. Minus. So, minus also. These are the arithmetic operation we know. This is, sorry, this is minus is here, dot is not there. Okay, now from q 1 we will be remain at q 1 with any of the input as digits. So, 0 1 to 9, and from q 2 q 1 if we go to q 2, if we see a dot as a input, and here q 4 if we see a digit or any of the digit 1 to 0 to 9, and then from q 2 again if we see a digit 0 1 to 9, we go to q 3, and from q 4 if we see a dot, we go to q 3, and from q 3 if we see another digit, we will be at q 3, and then by the epsilon move we can go to q 5, and this is as a final state. This is our final state. So, our sigma is plus, these are the operation, and we have 0 1 2 up to 9, all the digits, and we have a epsilon move. So, with the epsilon move we have this operations. Okay. Now, for this we want to find the language, we want to see what are the string accepted by this. So, we can see only the epsilon is not accepted by this string, because if we have epsilon at most we can go to q 1, but we have to reach to q 5 in order to have a string to be accepted. Okay. So, we will see what are the string will be accepted by this epsilon NFA. Okay. Now, we want to see 5 dot 6, this is our W say. 5 is coming from here. So, these are all string of alphabets 5.6. So, what we do? We start with q 0, then we can go to with epsilon move we can go to q 1. Okay. Then from q 1 again we can we can go to q 1, and then from q 1 we can go to we see a 5. So, this is epsilon, we see a 5 over here, then we can go to q 4, because q 4 we can go by seeing any digit in the tape. From q 4 we see a dot, with dot we can go to q 3. This is one of the path. There are many other paths are there. So, we will construct those. So, we can go to q 3 by seeing dot, and then from q 3 we can hop at q 3 by seeing this 6 q 3, and then with the epsilon move we can go to q 5, which is the final state. So, this is accepted. So, this belongs to L of E. This is the acceptance string. Okay. So, because this is giving one path, there are other paths. This is not delta hat q 0 this. So, this is one path, there are many other paths. So, for those we have to find the epsilon closure of these, we can try with that. Yeah. So, suppose you want to compute delta hat of q 0 5,6 5.6. This is a string, and we just shown in a one path it is accepting, but what are the other path? I mean, like if we have to compute this will be a set. So, to find this is nothing but epsilon closure of the set delta hat of q 0 5 dot comma 6. Okay, because this is we remember x a, this is our a, this is x, both together. So, this again we can write as 5 comma dot. If we write 5 comma dot delta hat of q 0 5 comma dot, this also we can write epsilon closure of delta of, this is a set q 0 5 comma dot, okay, delta hat of. Now, again to find this is delta hat. So, it is not delta hat involves the epsilon move also. So, delta hat of q 0 5, it is nothing but epsilon closure of delta hat of q 0 epsilon comma 5. Okay. Take this place now. Okay. Now, we can get this. This is epsilon closure of q 0. So, what is the epsilon closure of q 0? So, epsilon closure of q 0 is nothing but only q 0 and q 1, because we can with epsilon move we can go to q 1 or we can remain at q 0. Okay. So, this set is nothing but q 0 and q 1. So, from q 0 q 1 with 5 we can go from where to where. So, from q 0 q 1 we can go to, so this we can write as q 0 q 1, back calculation we will do now. Okay. Now, this is basically epsilon closure of q 0 and q 0 comma 5, epsilon closure of q 0 comma 5 and union of delta of q 0 q 1 comma 5. So, this will give us q 0 comma 5 is we know where to move. So, from q 1 comma 5 we can go to, this is empty. So, because from q 0 there is no move with the digit, but this one is q 0 comma 5, from q 0 comma 5 we can go to q 0 q 1 comma 5, q 1 and q 4. So, this set is nothing but q 1 comma q 4. So, this will give us q 1 comma q 4. So, this set is q 1 comma q 4. So, this we put it here. This is the epsilon closure of delta of, so q 1 comma q 4. So, if you continue like this, we will be getting this to be eventually q 1 and q 4. Q 1 q 4, and if we continue like this, we will be getting q 0 q 4 and finally, we will get q 5 also here. So, this q 5 will be subset of this if you continue like this. So, from here we can say this is, otherwise we can just compute whole string, that will be given in the lecture note. Okay. So, now we want to see how we can, given a epsilon NFA, how we can construct a equivalent NFA. So, that is our next target. So, epsilon NFA to NFA, that we want to see how we can construct a epsilon NFA to NFA. So, suppose we have given a epsilon NFA M or E. Q 0 F. Okay. So, now here delta is we can have delta is basically a function from q cross power set of q. Now, from here we have to construct a, this is epsilon NFA. Okay. So, now from here we have to construct a NFA n such that with the same state will be same, input alphabet will be same, only thing will change this delta to delta. So, q 0 will be same and f prime we need to change, f prime will change. So, you have to construct this such that L of okay. So, they are accepting the same language, this we have to construct. So, how we will construct this delta prime, to construct the delta prime, basically NFA has no epsilon move. So, we can just add the epsilon closure. So, basically we are going to add epsilon closure of the state, that is all. So, let us define this. So, for epsilon NFA, what we have? We have a delta, we start with q, I mean from a state, and this is a member of this is a power set of, this is some states. Now, there is a difference between this and this, because here we are just defining the, we are including the epsilon closure of this from both the side. So, this will be our delta prime. So, delta prime is nothing but delta prime of q comma a is basically delta hat of q comma a, and this is true for all q belongs to q and all a belongs to sigma. This is the way how we define the delta hat. This delta hat is the NFA, this our NFA is transition rule is delta hat, q 0 is same, only a prime we need to define, and delta has this defined. So, that means we are just from q 0 we are taking all the epsilon closure and we are reaching there, and from there we take a move with this delta with the input A, and then we reach to the another sets of states, and from there again there is an option to take the epsilon move. So, we include all of this. So, that is nothing but our delta hat, because we have seen there is a difference between. So, our epsilon in NFA is q sigma delta q 0 f. Now, this one is with the, we can define this as on A and epsilon, but there is no movement of epsilon here. Okay. So, what is the, so basically we, how is this defined? So, we are at q. Now, we consider the epsilon closure of this. So, that means, if all the path by only epsilon arc we can go, say R 1 R 2 say R k. Okay. Then from R 1 R 2 R 1 by A we can go to some of the R 1, then for with R 2 also we can go to R 2 R k like this. So, these are the set of states. Now, again from this set of the state we can go by epsilon move. So, this is our all epsilon move, these are all epsilon move. So, these are all basically our, these states are basically nothing but delta prime of q comma a, delta prime is this one, and this is nothing but we know delta hat of q comma a. Okay. Because for delta hat we are accepting a alphabet as a string. So, string is having a if we consider w, a is epsilon, a epsilon. Okay. So, before that we can have a epsilon move, and after that also we can have a epsilon move. So, this is the string. Okay. So, this is the way. Now, what is f? F prime. Now, what is f prime? So, f prime is nothing but if we include q 0, if epsilon closure of q 0 and f is not empty, otherwise it is f, because with the epsilon move only we can, if we are, so we are at q 0. So, with the epsilon move if we can reach to the any one of the final state of f, then we have to add q 0, because that will come under this this f prime, otherwise it is f prime if there is no epsilon closure of q 0 belongs to the contain the final state. Okay. So, this is the way we construct epsilon NFA to NFA. So, in the next class we will discuss two example of such construction. Thank you.